Hello, welcome everybody. Good day. Thank you for joining us. We've got a great topic here. My name is Mitch Ashley. I'm CTO of the company that hosts DevOps.com and these webinars, and also an analyst with one of our companies. So, pleased to be here. We have a great topic. Our topic today is, what does it mean to be DevKubeOps? So we're compacting three things together there. And I think we're going to have a lot of fun exploring that and really kind of diving into, from a developer, architecture, development team perspective, what people are doing with Kubernetes and where they are, and maybe what some of those challenges are. So I'd love you to join me in welcoming our co-speaker today, who's Nick Vermondi. He is Principal Developer Advocate with Onda. Welcome, Nick.
Thank you, Mitch. Thank you for having me. So obviously I'm not Rom, so we changed speaker. Unfortunately, Rom is a bit unwell, so I'm replacing him today, but I'm very happy to be there. Effectively, I'm a principal developer advocate at Onda, which I joined about 4 months ago now. So yeah, again, thank you for having me, and hopefully it's going to be a very fun session. I like those topics.
You bet. Thanks for standing in today. Unfortunately, you're very comfortable doing these kinds of things. Let me take care of a little bit of a housekeeping for folks. And I apologize for the echo. For whatever reason, my Mac and other equipment decided to battle each other a little bit today. So we've got a slight echo there. Hopefully it's not too distracting. We are recording this webinar, so if you want to take notes or jot something down, that's fine too. But you can also listen to the recording, watch the recording, share it with others, etc. So don't feel like you have to get every net thing down, because you can go back later and check it out. We also are giving away 4 Amazon gift cards at the end of today's webinar, so hang tight. Find out if you're one of our winners. We love to give those things away. And there's something about this platform that we're on. It's actually seems really conducive for audience engagement. I don't know about you. I'm not real keen on being talked to or talked at. I like to be talked with. And so you can engage in the conversation with Nick and I through the chat, either by asking questions or posting something in chat. And it could be a comment, could be a question, could be a thought, and a lot of times we'll draw on some of the things that are being discussed there. That may be the next sort of topic or question, unplanned even, that we may explore. So you can actually shape and drive a large part of the conversation here. And thank you, folks, for jumping in, sharing where you're from. So if you would do that, hop on chat, let us know what part of the earth you're joining us from today. So let's get back to our topic about DevKubeOps. So, Nick, let's start with just you introduce yourself as developer advocate with Onda. Tell us a little bit about Onda and what the company does.
Yeah, sure. So Onda, previously known as Storage OS. Maybe some people, know the previous company. We're still doing the same thing, not a big change. So the rebranding was merely to show the change of focus, right? So at Onda, we provide a data persistent services. So that makes sense. It's like vSAN, VMware vSAN. If people are familiar with vSAN and all the hyper-converged kind of platform, we do exactly the same thing, but for Kubernetes. So, but the goal is to do much more than that, right? Because Kubernetes is already a platform. So effectively, it has challenges with the underlying, storage features, things like replication, encryption, all of that. But fundamentally, we have to ask ourselves the question, why is it needed? Right? So the goal of Onda is to enable people to run stateful application inside Kubernetes. So when I'm talking about stateful application, this is anything from MySQL database, message queuing like Kafka, all those kind of things that needs to persist data to disk, or that needs to build specific things in order. Like if in Kubernetes, generally speaking, you can kill a pod, like a stateless workload, is going to be spun up somewhere else, right? And there's no data that is traditionally attached to it. If you want a stateful application, that's not the philosophy, right? The data needs to follow the workloads. And in Kubernetes, you cannot do that by default. There's no native construct that tells the storage has to follow the workloads. And what we are trying to do essentially is solve that problem but in a Kubernetes way. So by Kubernetes, I mean using Kubernetes and DevOps principle around automation. So you don't want to use yet another tool to define how your infrastructure and how your storage need to behave. You want to use YAML. You want to use things like templates, YAML templates, if you want to deploy in prod or in dev, all of that. So that's what we are focused on, is really bring this layer inside Kubernetes the most transparently possible for the end user. Yeah. Oh, you're on mute still. You have to remember.
Let's start here. I'm muting my mic to eliminate some of the echo, hopefully.
Yeah.
I always have to remind myself, Nick, that people are at different places on the journey, whether it's adopting DevOps or adopting Kubernetes or whatever it might be. And because you and I might live in that world all the time, I anyway sometimes forget, folks might be really starting out. They may be well down the path. As in your role, you get to, of course, talk to a lot of companies, a lot of developers, a lot of software teams. What is your assessment of kind of in general where most people are? Are we still in the beginning half of kind of adopting Kubernetes? Have we really accelerated into mainstream? I mean, if you read every site, you'd believe that every app is built with Kubernetes. We know it's not true, but it's a hot topic. So where do you think we kind of are in that adoption curve?
Yeah, sure. So I think there are two dimensions to answer this. The first one is about how people build application today or transform the application today, and the second one is how people are curious and they want to test things and see new technology that may be helping the business. So for the first one, it's really about packaging application, and I believe like legacy application, it's sometimes difficult to bring them inside Kubernetes. So, I mean, hyperscalers such as AWS and others start to release things to migrate from mainframe application into the cloud. So let's say modernization may go through something as a service, which is not Kubernetes, right? So for those very legacy application, very specific, it may be difficult if the whole business is focused on this type of application to say, yeah, let's move to Kubernetes. That doesn't make a lot of sense. But for any sort of enterprise application, like in-house application, web application, or user-based application, it makes a lot of sense to use Kubernetes, especially if you used to have all those components embedded into like the Java framework with all this middleware, WebLogic, all of that. This is the new pattern if you look at it. We started with this, WebLogic and Monolith and all these pipelines that were, well known and famous probably like 10, 15 years ago. Then we had a change with some additional patterns brought by people from Pivotal and all the Spring Boot kind of patterns, which was really the early days of microservices. And then we had this whole shift to agile methodology, right? And obviously that is setting the stage for container, right? So container is a way to package the application, that is very transportable. So you can, if your container is working on my laptop, then it's going to run everywhere, right? In the cloud, in a data center. That's fine. And then the step after that is, of course, now once you've played with containers, okay, I can maybe build my application using this. You need a way to deploy it into production. So you need all the traditional, production grade features, things like availability, performance, recoverability, manageability, security at the most cost efficient way possible. And for this, you need an orchestrator. And obviously, the Kubernetes is now, I would say, won the battle. We used to have, there's still Nomad, there's from HashiCorp, Mesos, there's and a couple of Docker Enterprise, all of that, and Swarm before that. But obviously, Kubernetes won the battle because so many, it's not because of Google, it's just because I mean, partly when Google started it, obviously, but there are so many people contributing to it now. And the CF grew so much as an organization, also with all the communities you have in Kubernetes. People just want to contribute and make use of something they can trust. So I think Kubernetes as a whole has reached the maturity level where anyone can use Kubernetes in production. But then this is more related to the second aspect to it. Problem is not necessarily about technology, it's more about people. You have to think about the operations, who is going to be looking after that. So maybe you have like a young guy, young student or female, out of the studies or out of university, first job, very tech savvy. He or she may be very eager to learn Kubernetes, or maybe even know some of the Docker Kubernetes aspect of running application. But let's face it, the workforce is much more than that. So there's also people who've been doing tens or dozens of years of working in operation with a more traditional model. So what do we do? They have to reinvent themselves, they have to learn. So it's kind of it depends on your recruitment strategy, how people are also if they want to learn more or learn a new technology. But I mean, if you're in this industry, it means that normally, I mean, everyone in IT knows that it's not a type of job where you can say, okay, I'm done with it. Right now, every day you have to learn something new. And I think this is mainly what is driving Kubernetes adoption is how the capability of people and companies to operate it, but operate in the best way possible.
Well, it's one thing about technologies, especially for wide adoption, it's almost as much about the ecosystem of things that go with it, people and other products, technologies, et cetera, that really help fuel that adoption. Just to share with you a little bit of my experience with you, Nick. Now, yeah, I've been a developer, still write a little bit of code, Python here and there, Node, et cetera. I was joking earlier about, old developers don't die, they just change programming languages. So, and I don't claim to be someone who's doing this every day, of course. But one of my experiences with dealing with a monolithic legacy app, it was actually a .NET app, when we first moved to the cloud, is we were really limited on how much change we could make because of the whole thing, a monolith problem, right? Making one change was really involved. So we actually carved off a part of the app where there was functionality that we needed to enhance, add, that was really going to be valuable to the business so we could do new things in market with. And that we rebuilt in Kubernetes, that we containerized, et cetera, kind of modernized a piece of it. So the whole app didn't have to be, you didn't have to eat the whole elephant, right? We picked up the part that would actually get benefit from doing something like with Kubernetes or in the cloud. And that was also a good way to kind of get started, get our feet wet and understand the new technology. Is that a common approach you've seen other people do? Is that sort of the rare exception? It's always more greenfield, starting from scratch. What do you see?
Well, I mean, from my experience, it's when you go to a app modernization type of journey, it takes time. So I would say it's not necessarily the main driver for adopting cloud or like public cloud, hyperscaler. Kubernetes is another story. Of course, if you need to modernize your application into, there's different way to do it. But typically, if you can say, okay, I've got this service that does that, this one that does that, you can. It rarely happens. It's difficult to map one microservice to part of your application. Sometimes you have to write it all the way, again. So, which is challenging. But so it's really like two dimension. One, you can go greenfield and start building new application for, like new businesses or a new feature you want to build. But at the same time, you cannot kill the old one. So you end up effectively pretty much every organization using Kubernetes end up at some point with a legacy platform running the old application that can not necessarily be migrated as is, together with a new environment where you start kind of mirroring some of the feature and enhancing it so that people would just use one and another over time, if that's possible. There's also things you can do, which is do a lift and shift inside Kubernetes. That's another reason. It's not my preferred reason, because obviously there's a lot of hidden things you will hit, a lot of hidden problems you don't see day one. But if you think about it, Kubernetes by itself brings a lot of features that are just implicitly running in Kubernetes. Things like so high availability, it's an orchestrator, the ability to restart workloads and to schedule them the proper way. It has all the network and security feature you can think of through the network plugin that can also integrate with your physical fabric if you're on-prem, or with your cloud load balancer if you're using a hyperscaler. So like service discovery, DNS, you don't have necessarily to worry about them within the cluster. So you can leverage a lot of the benefits there. But again, if that's a legacy application, typically it needs to store data. And this is where as Onda, we can also help, right? Is typically things like people can run hypervisor inside Kubernetes, right? So like KubeVirt. So KubeVirt is like a hypervisor that is spinning up a VM more or less with a container where you run a VM, right? So, but for this, you need data as well. You need to persist data for those kind of pet VM. So this is what is missing inside Kubernetes, but of course we can help with this. So legacy application, you can do it, but there's a lot of challenges you will have to solve. And if you develop a new application, same thing. All the traditional challenges around the development lifecycle, people tend to hard code a lot of stuff to configure the application, to configure a service. Then what people need to get in their mind is Kubernetes has already a lot of the primitive to configure application, like first class object inside Kubernetes for environment variable, all those kind of things. So you have to think the Kubernetes way when you're building this application, right? So you can do lift and shift, you can do greenfield, but both will have equally, they will have both challenges. Not the same ones, but there's no easy answer. And suddenly, but when you go to the cloud, public cloud, at least what you can have is basically a Kubernetes cluster production ready in less than 15 minutes. So at least you don't have to manage the whole, provisioning, hardware provisioning, ordering, talk to the network people, talk to the storage people to get the SAN provision, to get the VLAN provision, all of that. So that does remove a lot of the heavy lifting.
And oftentimes, to your point, you're doing more than one thing at once. You may be adopting Kubernetes containers, et cetera. And by the way, today's webinar is sponsored by Red Hat, and it's a series that we're doing with them. So we appreciate that very much. But you might be moving to an environment like that. That's a new environment that's more than just a hypervisor, right? Like you might be running in a traditional data center. And so you're kind of rethinking multiple parts of it. You're rethinking the software stack, you're rethinking going to microservices, or maybe you're lift and shift and moving to containers that way. What are some of the things that afford you to think about running in an environment? I'm not trying to do a commercial for Red Hat, but when you're running in an environment like that you can also take advantage of while you're moving to a kube kind of architecture.
Yeah. I mean, especially talking about Red Hat and their version of Kubernetes, which is obviously Openshift. They did a good job at just combining a lot of additional tools for the developer within the platform. Things like source to image, or just being able to do all the heavy lifting for packaging application into usable container. And the developer doesn't necessarily have to think too much about the packaging process. Just write your code, because let's face it, as a developer, I mean, not all of them, but I mean, the vast majority of developers, what they want to do is produce code. They don't want to be managing new paradigms within Kubernetes or things like that. This is generally the DevOps team or the platform engineer teams or SREs, however you want to call them. This is more that problem. So for the developer, ideally, it should be super simple. Right. So I'm not saying it's entirely super simple with Openshift, because there's still a lot of even more moving parts. But in terms of the developer tooling, we can call it a PaaS environment, so platform as a service, because you can leverage all these extra developer tools just to streamline the process of putting your code together and releasing it into production. Something that vanilla Kubernetes doesn't have. You will have to build sort of your own, or to use like other tools and do it yourself type of approach. Yeah.
I think that's a really good point. And I also was an early adopter of OpenShift. And one thing you appreciate about working both in cloud, but also in an environment like that is, sometimes there's things on the shelf, the virtual shelf you can use and pull down and use, whether it comes off the shelf or from the marketplace. But also having kind of an integrated, spend your time building the tools or making the tools work. A lot of that can be done for you. So, hats off. It's no pun intended there. I guess maybe it was. So I'm curious, as people move to, a microservices cloud native kind of architecture with that type of a pattern, and they're adopting Kubernetes with it, what are some of the pitfalls people usually run into? What would you see over and over common challenges that folks have to work through?
Yeah, I mean, one of the main challenge, as I said, and a couple of them, storage is one of them, obviously. Because the thing with microservices, when you adopt this pattern, so moving away from the monolith, in terms of people and the team responsible for those services, so we moved from a super large team with a single, super large database that is serving the data to all the different other components, to a much more kind of sparse, exploded model where you end up with a lot of different teams looking after one or several microservices. And those teams now, you will have different personas in these teams. It's not more like a big silos. It's more like combine roles into smaller teams that are responsible for one or a set of microservices. And within this team, you will end up with a DevOps person, developers, maybe database specialists, something like that. Now, every microservice, every team may or may not have like a specific database they use, and they need to store data. And this is where some of the challenges lie. Other challenge is about networking. How do you enable security? Like things like network policy, who can access the cluster, RBAC, multi-tenancy, all of that are challenges that people need to solve very early in the process, because after it's going to be too late. And the last, so infrastructure, Kubernetes, I like to see it as a data center in a box, because it does have all the traditional component of a data center, solution. So in the sense that you will face the same challenge. So think about it, right? If you have a brand new data center, you deploy your physical server, you maybe want to deploy a hypervisor and then start to build things. Those are the same challenges in Kubernetes, just a different way to solve them. But you have to it's the same process, right? It's not a different process. It just doesn't disappear magically, right? And the last point is more focused, I would say, on the application, which is, again, what I was saying before. You have to design your application not only as a container, right, but also leveraging the Kubernetes first-class, primitives, such as, how do I inject data or specific configuration in my application? How should I manage my secrets, my configuration maps? All this, we used to have, a lot of people used to do a lot of scripting around, like a wrapper around the application, how to initialize the application. And in Kubernetes, there's a lot of different patterns. So I've mentioned, secret, config map, environment variable, init container, sidecars, you name it. I mean, there's a lot of them. So the challenge is really to find the right pattern for your application and not end up in a situation where you're using an anti-pattern, basically.
Is that usually more of a trial and error? Is that a learn from others, kind of look at how people have applied them? How do you figure that out?
Yeah, I mean, personally, my recommendation is always look at others. So there's a lot of talk from, of course, big companies like Netflix, Zalando, all those people who are making use of cloud native technologies, and also books. Recently, I read a book which was the name it was Kubernetes Patterns for Application. It's really, really good book, and it goes even deeper than the traditional Kubernetes object. There's a lot of good, advice in terms of how to learn, how to deploy those new applications and to develop those applications within Kubernetes and avoid those pitfalls. But ultimately, Kubernetes is an area where you also learn by your mistakes. So it's like a startup. You want to fail fast, so try. If it works, continue. If it doesn't work, fail fast. Try something else within the cluster, another pattern. So you have to take all the other examples, combine them together, think about your own, test it, and just iterate again. Right? That's basically it.
So it's really easy and very common. We take the developer perspective, appropriately so, when we talk about Kubernetes. What about operationally from an ops perspective, whether it's truly developers doing ops or most of the time we still have operations people, whether they're SRE or, ops folks that are managing the infrastructure and all parts of the app, all of that, visibility, observability into that. How do you think about Kubernetes from that side of the coin?
Yeah, sure. So there's things you need to provide for all the operational support levels, level 1, level 2, level 3. Depending on that level, people will need different things. So probably level 1 of operation, you need basic things that are not necessarily different from Kubernetes, from a Kubernetes point of view. It's like a green light or red light type of things. So that doesn't change a lot. But the more you go into the troubleshooting, aspect of Kubernetes, the more tools you need to build within Kubernetes, because it doesn't come out of the box with a lot of operational to facilitate operations. So there are, of course, all the Kubernetes events, things like that, but to give you end-to-end visibility in terms of what is happening for a particular application, it can be super challenging. So you need if you need to build efficient dashboard, whatever stack you're using, if it's Elk, Prometheus, whatever, depending on your application. But you really need to work on that in terms of wrapping your application with a observability and instrumentation layer that does fit well. But also, even within the application, now you have to think about it in the way that, for example, if you want to build a Prometheus endpoint, it has to sit within the application. So you have to build new libraries. You have to think about that. How, from day one, how are you going to monitor and provide all this instrumentation, starting with the application? Think like distributed tracing, because of these microservices, you need to be able to say, okay, now, for that particular request that failed, it's going, it's flowing between all those different microservices. You need to be able to measure, the total request, all the different sub requests, and you need this distributed tracing. But guess what? You need to modify the application code to make it happen, right? So if you really want to do it the proper way, it's definitely day one when you're thinking about your application and Kubernetes strategy. Then you have to think about all those components and make a choice. Yeah.
It's maybe easy to kind of wrap things in containers, but it isn't always the most effective, at least, doing that. I'm curious too about you, of course, coming at this from an ONDAP perspective. I know questions I've heard asked are, what about data? Do we put database engines or technologies? Do we wrap those in containers? How do we distribute it? What are things we need to think through? So as you look at the data side of this, what are some of the questions that you might ask yourself or need to answer to help decide what's the best way to implement that in a Kube environment?
Yeah, so I would say there's a couple of things. So first of all, is Kubernetes ready for data? That's the main question. Historically, if you look at how Kubernetes evolved over time, from the very beginning, we had this notion of, it was called pet sets, and they changed the name later, but I think that was early 2016. Yeah, 2016, that was the pet sets creation. So you could feel that there was this need day one to host stateful application, right? So stateful application means application that needs data, right? But if you the comparison, if you were to compare the stateful application to the stateless, then obviously the stateless part was much more advanced compared to the stateful ones. So you had a lot more tools available to run container in Kubernetes as stateless apps. So it was not, the question was not even worth asking. No, Kubernetes was not ready to host stateful data. But over time, they brought the same benefits as what is currently there for what was there for traditional stateless application into the stateful sets. Things like rolling upgrades, guaranteeing that you have always the desired amount of workload that is running at any point in time, even during upgrades, all of that. So over time we had this, and then we had storage class, and then dynamic provisioning, which was really important because at the beginning with Kubernetes, the platform admin had to pre-provision everything as a storage pool, like, okay, I'm going to provision this volume, this volume, this volume. And now the developers, they are going to consume that. Now it's not more like that. So what you do today, you use a provider like Onda, but also others, like cloud providers as well, like EBS or whatever, that will automatically provision storage on demand. So when the developer needs it, no one has to go behind the scene and take time to provision effectively the storage behind it. So that was another tool that was required for hosting data inside Kubernetes. So that was probably a couple of years ago, like 2018, something like that, 3 years ago, that we could do that. But that was not enough, right? Now what we see for probably less than 2 years is database vendors and other companies, even like the community, are building what we call database operators. So if people are not familiar with the operator model, it's all about automation and reacting to specific events, and based on those events, doing things inside Kubernetes or somewhere else. But the idea is when Kubernetes is sent an event, then it's going to do something else, right? That's the idea of an operator. Basically replacing a physical, human operator. That's why it's called an operator. And what database operator does for you is, so when you are scaling your application, right? Let's say you have a MySQL cluster, 3-node MySQL cluster, and you want to have more resiliency, more power, maybe if it's Mongo, maybe more read replicas, these kind of things. So you need to scale the number of containers that are part of your stateful application. So Kubernetes could always do that. So just scale the number of workloads. But now you also need to scale your database that is sitting on top, right? So your database cluster need to have more, more nodes. And basically, that is what the operator, the database operator, is doing. It's reacting on an external event. So that can be install a database. So it starts with the database installation. But also as you scale up and down, or you scale out and down your application, your database, then the operator will make sure that the application is also scaled at the same time as the workloads themselves. So now, that's a lot, right? We have the stateful set feature inside Kubernetes, storage class, we can do dynamic provisioning, database operator, and now the last one is, of course, again, the Kubernetes doesn't guarantee that you will have this amount of performance, this amount of number of replicas, doesn't do replication, doesn't do disaster recovery, doesn't do backup. You can do snapshot, but you rely on the storage solution to do it for you. So you have to pick the right solution for, that underpins all these databases and all this data. So of course, Onda is one of the solutions. I've mentioned in the cloud, there's EBS, but you can also use Onda in the cloud. We can talk about this a bit later, what we can bring on top of that. But my point is there are a lot of different solutions, but you have to evaluate them to the same, in the same principle, you have to evaluate a CNI, which is the container network interface. So you have to find the right networking solution for you that integrate with your requirements, whether it's on-prem or in the cloud, load balancer, all of that. Now you need to do the same thing with the CSI, which is the container storage interface. So the layer that is going to provide you all these extra, persistent data layer or services, right? So this is something that you have to bear in mind. Yeah. So yeah, where I was going with this actually is, sorry for that, is with all those components together, then I can say now, if you have this done the proper way, then data can be hosted on Kubernetes. And there's actually a community which is called Data on Kubernetes community. So if you're interested in this, it's called dok.community, I believe. And there's a lot of content you can browse and learn around those aspects.
As listening to you describe this, I can think of a lot of questions. One is, this is an environment where you have to go download, source, and build Kubernetes from scratch. There's a lot of distributions available through all kinds of different providers, cloud, et cetera, platforms, even VMware, has their own distribution. As you think about it, what helps you get started on the right path for figuring out how do we set up this environment? Do we experiment with a couple of different distros? Do we go with the vendors that we know we trust? That's just one tiny question of how do you create this environment, right?
Yeah, no, you're right. I think in terms of the distribution, there are two layers, I would say. The first one is, where do you want to run your Kubernetes cluster? So that will limit the choices you can make. So typically, if your company is not cloud first, my experience is that usually people will try to do it on-prem. So on-prem, there's basically two options. You do it on bare metal nodes, or you do it with a hypervisor. Let's say VMware. So if you pick VMware, so of course you may want to go Tanzu, right? Or you may want to go Openshift as well, right? Because Openshift can be deployed in VMware. You can go Rancher as well, which is a great solution for managing heterogeneous Kubernetes cluster deployed in various locations. But let's say the number of choices are a bit limited, right? So, but if your data center first, this is you have to find one of those solutions you can run on-prem. But then you also have to think about day two. Do you want to also extend to public cloud, to hyperscaler, whether it's AWS, Azure, Google? So they all have managed Kubernetes solution. So whether it's GKE for Google, AKS, Microsoft, and EKS for AWS, and then again you can have something like Rancher to manage them all if you need this kind of single pane of glass for all your cluster. Which may be, that's maybe super useful, but at the same time, you have to think about, do I need to connect them together, or what's my strategy for multi-cloud, or do I need, recently, 2 days ago, AWS had a big failure, right? Really, really big failure. Impacted a lot of people, even impacted me on my iFit, Nordic Track treadmill, where I was trying to run. I was like, what's happening? And this is where I noticed, it's AWS is failing, and in unexpected consequence, I cannot use the software I'm using just to train at home. Very weird. Anyway, but the point is, some people said, it's not a valid reason to go for multi-cloud, right? Technically, if one cloud provider doesn't have an issue, it's not a valid. I don't think it's right, because if you think about it, Kubernetes, it's the de facto cloud operating system. So as long as you have a team and you have the right skill set, of course, you can build any of the AWS or any service into Kubernetes and just consume EKS in AWS, AKS in Azure, etc. But you have a consistent platform, development platform, where you can deploy your homemade services regardless of the cloud platform. So if high availability is really important, if cloud agnosticity is important, and if you have the right skill set or ready to spend money on the right skill set, then it's obviously the ideal solution, right? So then you can have a bit of EKS, AKS, doesn't really matter. And on-prem, now we can see a lot of different solutions. You can run EKS on Outpost. You can run open source EKS, EKS-A, EKS anywhere, essentially from AWS. You can have Anthos. So you can mix and match depending on your, what your teams is the most comfortable with. But to me, like the real question, you should, if you want to go, let's go microservices and Kubernetes all the way, to me, there's no reason to go to a single cloud, except if you want to use like cloud-specific services like DB as a service on top of that. But I would stay away from that if you're using Kubernetes, because the assumption is that now you have the skill set for that, the knowledge, and things like Lambdas or function as a service. Well, there is Knative. For ML, well, there is Kubeflow, which is kind of a fork of TensorFlow from Google. So any type of workloads in the end can run in Kubernetes. Any service can run there, as long as you put enough time and effort from people. But to be honest, the reality is, even for hyperscaler, consuming as a service is not like one click. If you want to build a real application, end-to-end application in AWS, for example, using, 15 different services, you're going to have to put a lot of glue there anyway, right? So you're going to spend a lot of time architecting the application with an AWS solutions architect, with a partner. And to be honest, I think it's going to take as much time as building it inside an environment like Kubernetes. And in the end, on the long term, it's going to probably be even more expensive.
Interesting. You have to keep clicking my mic on and off here. I was thinking about the data part of this too. We were talking about data a little bit earlier. Data brings with it its own challenges. One of them is, of course, the model of where the data is at. You don't change database structures on the fly like you might code. But another challenge is also location. Right? Data can be at the edge. Data can be in different clouds. Data can be back in the data center, can be distributed across all that, not necessarily in a highly usable way, or it could be usable. So how do you think about your data strategy in a kube environment when you're talking either one cloud, multi-cloud, hybrid with a corporate data center?
So I would say, excuse me, there's multiple angles again. Depend, if you're ready to migrate your data into Kubernetes, is this something that operationally you're ready to absorb? Then the problems is automatically, I would say, solved for you, right? Because the data is collocated the closest possible to your application. Because Sherry Hung, who is the part of used to be part of the CNCF, used to say that there's no such thing as a stateless architecture. It's just someone else's problem in the end. And that's pretty true, right? So if you choose to bring it inside Kubernetes, it becomes the SRE issue. If you want to keep outside, it's just the DBA issue. Or the DBA, if he's ready to go and to learn Kubernetes, then even better. So there is this aspect. You want to move the application the database where you have the less possible latency, which is closest possible to the stateless component, probably maybe running in Kubernetes. Now, in terms of the edge, this is where it's also becoming very interesting, because at the edge, you can also deploy Kubernetes. There are minimum distribution of Kubernetes, like K3S, this kind of stuff. But again, it depends on the type of database. If you need to do some basic transformation and store stuff there, then that's fine. You can run like a minimum Kubernetes distribution. But if you need like a lot of performance at the edge, so probably, K3S, which is a rancher minimal distribution, won't be the right fit, right? So if you can have like a large Kubernetes cluster at the edge, it's okay. Otherwise, again, if it's if you need to be in a specific region, then you can deploy, a managed Kubernetes cluster there. And the good thing is, as long as you have the right, persistent storage solution, data can be removed. And what we like to say on that is our goal is really to remove data gravity, so that you can move from one cluster to another, the closest possible to your ideal region or availability zone, and also provide disaster recovery across different availability zone, which you don't have natively necessarily, right? You have to plan for it. How do you do multi-AZ failover or multi-region failover becomes also a problem you need to solve. So either you solve it using cloud specific services in the hyperscaler, so using some Lambda function and replicating things, or you can also use a storage solution to replicate across availability zone as well, right? So that if one node fail, the workload is restarting and the data is already there, ready to be consumed, right? So it depends on RTO, RPO, all of that. So edge is it can be challenging in terms of finding the right location with the right distribution. But typically, I would still, if you can afford like a smaller K3s cluster, not a lot of performance, that would be my preferred way to drive data. Otherwise, again, Kubernetes cluster, the closest possible to the application. And for the old model, if it's not latency sensitive, then that's fine. You can run still your MySQL on VMware and have your stateless application running in Kubernetes somewhere in the data center, or even in the cloud, right? But then you have to be careful about the performance. Yeah.
It's an interesting idea. I hadn't thought about K3S, because usually I think about it as the environments like IoT devices and things that don't have a lot of, capacity or performance. Is there a certain kind of data environment that would really be well suited to a K3S setup?
So K3S, I mean, I don't know. In terms of the storage performance, this wouldn't be an issue. Like, again, I'm working for that, so I'm taking the example with Onda. If you have very small, NVMe drives, we will use them so locally. So the performance is a lot better than a traditional, even like a SAN from a couple of years ago, right? With different, caching, we can go faster just using NVMe. But it's more on the CPU, the memory, and all of that you have to be careful around the database. So if the database needs a lot of memory, probably K3S is not the right fit. But for storage, it can be. We're just relying on local NVMe drive, and we aggregate all the performance of those, which actually gives you real shocking performance. It's awesome, really. So it's not the bottleneck. The bottleneck in those environments, because in 2021 the disk drives, they are like NVMe like that, right? So it's more around the memory, the CPU you can put at the edge. Or if you want to go with a hyperscaler, again, normally they should give you like more performance within their own data center at the edge. And in that case, you can run database in Kubernetes like you would run anywhere. It's just another Kubernetes cluster. But Kubernetes at the edge is also a big use case. We see more and more if you watch on YouTube all the CNCF, the KubeCon events. There's a lot of talks around using Kubernetes at the edge for 5G. A lot of telco actually use. I used to work for Cisco, and even at Cisco, we had a lot of discussion with service providers around 5G and how to put the control plane components within containerized environments. So this is a very hot topic as well.
Now, as I understand on that, and you obviously know it much better than I do, but that ability to go across clusters and kind of present data as a pool to applications, right? So you're not kind of limited into one environment, one of set of cluster environments that you've set up. Are there other things that Ondat does that helps you from a data or a kube perspective we should know about?
Yeah, sure. So I was mentioning just before, one of the challenge of using cloud persistent drive is the replication across availability zone. Because again, if you create a regional cluster, Kubernetes cluster, so potentially using, let's say, 3 availability zone, by default is if one of the node fail in one availability zone, and you need to restart the workload, the stateful workload, the data doesn't follow by default, right? You have to do it yourself. Those kind of aspects has to be managed outside of Kubernetes. So with Onda, we have a feature that is called Topology Aware Placement. So we will detect, and the cloud, the hyperscaler, they do it properly, they do it the right way, because when you deploy a managed cluster, it will populate what we call a topology key within the cluster, specifying the zone of the node. And we rely on that specific field to replicate the volume and to make sure that they are spread across different availability zones, so that you don't have all the volume in one zone, for example. So they are all equally spread across the availability zone, so that the node fail, the workload gets restarted in another availability zone, but guess what? The data is already there. So it's in a matter of seconds, it's like automatic restart of workload. So of course, there is still the application clustering aspects, right? Even if you lose a node, you still have your MySQL Mongo cluster that will be running and in a degraded mode. But what you want is to go to this nominal mode as soon as possible, as fast as possible. So for that, yeah, with on that, for example, and this particular feature, the database, I mean, one node of the database will be restarted as fast as possible into another availability zone. So you can avoid, like, bad surprises running things inside Kubernetes. Another one, which is encryption. As a company, enterprise, they want to keep their data a bit secret. Like if you run in AWS, you don't want AWS to be able to look into your data or the support or anything. Now, if you use end-to-end AWS encryption, guess what? Well, you encrypt with encryption key, and those keys, they are stored where? In AWS, right? So you put all your eggs in the same basket. So what we do, as an example, again, Kubernetes way, just by using labels, Kubernetes object, you can say, okay, now I want to encrypt my data at rest. So all the volume individually will be encrypted by using an encryption key that is stored within Kubernetes, right? And then by default, we will encrypt everything in transit. So even if within a multi-AZ cluster, all the data that transit for replication, all that, everything is encrypted, mutual TLS, all the kind of security best practices there as well. So it's really important to provide this to customers, because you want to keep these things, for yourself. Right? You don't want to share this with the world.
Well, one of the things I want to make sure we take care of before we get to the end of our time, we were giving away 4 gift certificates, and I want to announce our winners. Excuse me. Our winners are Francisco M., Moshe E., Eric B., and Rory M. The folks at DevOps.com. Textron Group will be reaching out to you to find out how to get a hold of those. So congratulations to our winners. So one of the things I'd like to wrap up with, Nick, is I don't know why, but I'm really pumped about SRE and observability and tracing and things like that. And one of the reasons is, and DevOps has kind of helped lift, a rising tide lifts all boats, that kind of idea. But in a way, those things have made operations kind of sexy. And maybe for the first time. Sorry to use that word. Maybe that's not the best word to use it, but it's cool again. Maybe that's the way to say it. And I'm curious, from your perspective, what are some SRE kinds of reliability or performance improvement engineering kinds of tasks that SREs either are taking on or might consider doing in a kube environment?
Yeah, so if I take our example, as a startup, we do have SREs, which are not called SREs, but this is basically their jobs. And I think it's quite close to what the SRE job is, which is part of it is ensuring that the software is good quality. So kind of a QA role, right? That's one of them. So building all the automation, this is all the DevOps things, like making sure the pipelines are okay. We're doing all the test coverage, all of that are in a good shape. And then there is the production aspect of it. where you have to make sure you have the right instrumentation tool. And again, it can be things like, okay, let's create some eBPF programs. Like eBPF is quite also hype at the moment because it gives you the ability to create this small program that have direct hook into the kernel, but still, it's just JIT. Like from the user space, you can switch to kernel space like that and get all this super useful information, very optimized, for performance, etc., etc. And their job is really to start thinking about all those tooling and what best apply to their particular software they need to maintain in production. And you're right. What is sexy in this is like every week is a new tool. So for people who really like learning, I'm an avid learner. I like to learn anything about technology. I like to read about technology. I just live and breathe about technologies, especially around the Kubernetes and container aspect and software engineering, all of that. So you just can help yourself, but testing all those new toys. And some of them you don't want to use it, but some of them may be super relevant for your production environment. And all this instrumentation is actually, the goal is really to react as fast as possible when you have issues in production and to maintain these green lights as long as possible. So this is a very interesting job because it combines both like sysadmin skills. You have to know Linux or Windows maybe. Deep down, you have to master all containers, Kubernetes, the DevOps aspect, but also you have to know how to code. You need to understand the application. You need to talk to developers, so you need to speak the same language. So it's all in one package, So it's really a new kind of role. Before that, we had just sysadmins. The job of the sysadmins one was essentially this, maintaining the system and the application. But the application, with microservices, there's a lot of moving parts, and they're just connected by networking. So there's a lot more, concept around those because you need to connect them together. So again, with Kubernetes service discovery, all those application wrapper, all those objects, Kubernetes object popping up everywhere and disappearing, million times a day. So that makes, you're right. That makes the whole, this whole kind of area super interesting and super fun at the same time because it's got a lot of trends for sure.
It's not necessarily a perfect analogy, but I'd often describe it as, compare one cube environment to a Rubik's Cube that's constantly moving. In a way, it's kind of the environment that we're talking about. Your passion for learning reminds me of long ago in a galaxy far, far away when I was in college. My CS professor said, everything you learned here is going to be out of date in 6 months. I think it's 6 minutes now, but I think it's accelerated a lot. So a passion for learning is certainly a great attribute to have. Well, Nick, I want to thank you for leading our conversation today and sharing
my pleasure
your knowledge, and as well as all the things that you've gained from working with people in the cloud and in Red Hat environments and Kube with data, all of those things. So just as a bit of wrap up, a reminder that we will email everybody that signed up for today's webinar. We'll send in that a link to the recording. Fortunately, there will be no slides attached because we didn't use any slides. And congratulations again to our winners. I want to thank Nick Raimondi, who is Principal Developer Advocate with
If I can
Onda.
just add one thing. So
please.
We are heavily recruiting. So if you want to work for Onda, where also the cool stuff happen, feel free to go on onda.io in the job section. Even if the job is not open, you can contact me or the company on LinkedIn, whatever. We're recruiting.
Awesome. Great. Get a nice little recruiting plug in there. Fantastic. And Ondat is ondat.io, right?
Correct.
Where folks can go. Great. Please check them out. Thanks for joining us today. We hope that you've gotten some good information. We really appreciate Nick sharing with us, and we appreciate you taking your time to spend with us. So have a great rest of your day. Have a great time as we lead into the holidays and into 2022. Thanks again for joining us. Be safe and be well.